So in this next section, 7.6, what we're going to end up doing is taking a look at problems that have a little bit more to them. If we took an example like we had x squared plus 4x plus 3, from the stuff we've been doing before, we would just take a look at what are the different factors of 3. So we have 1 and 3, right? And so 1 and 3 can come together to make 4. And so I'd put 1 here, 3 here, and we'd be done. And that's the opposite of FOIL. In this next section, what we're doing is we're going to now say what happens if, a little more complicated, and what if we had a 4 or some kind of number in front of the x right there. And this is going to kind of change everything. It's going to make it a little bit more of a challenge. So if I had a 4 there, now I have to figure out, right, instead of just x times x is x squared, we have to figure out what times what is 4, what times what is 3, but also when we do some adding together, we get 4 here in the middle. So it makes it a little bit more complicated. So that's what we're looking at now on 7.6. So as we jump into this next part, if you want to have the textbook out there in front of you, we're looking at page 392 and 393. We're going to do examples 1 and example 4 because they actually have more in common than 2 and 3. So we'll look at 1 and 4, even though they're kind of separated in the book. And we'll see that they are kind of the opposite of distributive property, right? Distributive property means you have a number on the outside and you're distributing it through. This is going to be the opposite way. It's going to be taking a common factor on the inside, and then we're pulling it back out of the actual expression that we're looking at. So if you look at example number 1, which is on 392, let me just make sure I got my numbers here. 5, right? We have 5x, right, and that's squared. And then we have plus 15x, and then plus 10. All right, so all I'm doing is looking at example number 1. All right, so example number 1 on page 392. All right, so if you want to follow right along with us here, as we're doing this here in class like we normally would. All right, so what's happening in this case is that we have something going on. We have a number in front of the x in this section. So we have a 5 there. We haven't had that before. And if we're trying to figure out exactly, right, normally we just go ahead and make our parentheses and figure out x times x can be x squared. What times what is 10 that adds the middle. But in this case, right, we can't quite do that. And so the first thing we want to do is find what's called the greatest common factor. Is there a number that we can pull out and make this thing a little bit easier? And maybe it'll give us a chance or a shot at actually trying to solve this. And typically, as long as we know our times tables, when we look at these numbers, they're not going to be so big and crazy that we can't make sense out of them. We have a multiple of 5 here, a multiple of 5 here, and a multiple of 5 here. Right? So this is 5 times 1 is 5. 3 times 5 is 15, and 2 times 5 is 10. So they all have a 5 in common. So if I went ahead and I borrowed a 5 from each of these and I pulled this outside of the parentheses, right? And so if I go ahead and I write 5 in red here so it stands out, right? I pulled out a 5, and so what happens is, right, if I borrowed a 5 from here, I'm just left with x squared. I took away, right, borrowed a 5 from this one, right? 3 times 5 is 15. So if I borrow 5, I'm left with 3, just x. And if I think about my times tables, 2 times 5 is going to be 10. So if I borrow 5 and I take it on out, I'm now left with just 2. I can double check my work, make sure everything works out. So again, if I go 5 times x squared is 5x. 5 times 3 is 15x. And then 5 times 2 is 10, right? And so we've broken this down. Now, at this point, it may be possible to break this down a little farther, and in this case, it actually does break down a little farther. So this by itself, I can go ahead and see that if I was going to break this down, right now, all I have to do is just pull out the greatest common factor, but we can see that this now breaks down a little easier. So this in and by itself is going to be just x squared. Different ways to get 2. If I look at all the factors of 2, right, it's going to be just, in this case, just 1 times 2. That's the only way to do this. So I only have basically one option. So I have 1 there, and since it's a positive 2, I'm going to be a positive times a positive. It might be possibly a negative times a negative, but in this case, if I had a negative and negative added together, it would be negative 3. So this is going to be positive, right, and positive, or adding and adding. And so now I can double check x times x is x squared. My last 2 times 1 is 2. And when I multiply the 2 in the middle here, 1 times x is 1x. Right, x times 2x is 2x. And if I add those together, it does come out to 3x. So this does work and it checks. Now remember that I did pull out a 5. So if I get rid of this here, right, I still have this 5 out in front. And so if I write down that 5, I have now gone ahead and I have factored that like a factor tree as far as it can go. So the big lesson today is, can we pull out a number before we even start doing any factoring of the problems? Many times all we're doing today is just actually pulling out some number that they have in common, and then that's the end of it. But we could now add together, like pieces of a puzzle, also the factoring one more step, and that's where we're eventually going with this. So again, baby steps as we try to do this. For this next example, it's not right there in the book as you're looking at page 392. I just pulled up another one so we can look at it and you can see what we just did with the example number 1 in the book there. Right, I come across a problem like this one. I think I just pulled this out of the back from the exercises there. But we are going ahead and we're taking a look, right? Big challenge we have a number in front here. So the first thing we're going to do is we're going to go ahead and see if we can pull out any numbers or factors that they have in common and try to simplify this thing. Hopefully getting rid of the numbers that are in front of our r squared, because that's going to make our factoring a lot easier, as we've seen with the previous stuff we've done. So as I take a look here, right, I see there's a 9. In my brain, you're starting to see 4 times 9 is going to be 36, so that might work. And then 5 times 9 is also 45. So each one of these has a factor of 9 that I can pull out. So I'm going to go ahead, I'm going to pull out a 9. I'm going to make myself a set of parentheses here. And then I'm going to see what I have left. All right. So I'll set myself up a set of parentheses. If I borrow 9 from the r squared, I'm just left with r squared minus, I've pulled out a 9. 36 is going to be 4 times 9. So if I pull out a 9, right, again, the opposite of distributing the 9 through, I'm pulling this back out. All right, 4 times 9 is going to be 36. So if I pull out a 9, I'm left with just 4r. And then minus, and I have 45 right there. And I'm thinking in my brain, yes, 5 times 9 is 45. So if I pull out a 9, I'm just left with 5. And so that is pulling out the greatest common factor. So now if I look at this, this can break down, right? And so as we were doing before, if I just covered up that 9, this will break down, pulling out or finding the greatest common factor, really set this thing up so we can actually do something with it. And so in this case, I take a look, right? This will break down. So I'm going to keep track of this 9. I'm just going to bring this 9 on down right there and just keep it off to the side. And then if I take a look at what I have here left, right, if it does break down, we're fine. And if it doesn't break down, it may be the case eventually they don't break down. We just have to pull out the one number that they all have in common. But in this case, I have an r and an r right there, because again, r times r is my r squared. For the 5, I have to figure out what times what, right? So I have 5. Again, most of these that we're doing right now are prime numbers, or fairly easy. They don't have a lot of factors. They can get very complicated if we have a lot of different factors. But in this case, 1 and 5, and so I know all my only options for numbers right there is going to be 5, and I'm trying to figure out what times what's going to be a negative 5, but then when I add them together, since I'm adding the middle, it's going to be negative 4. So if I take a look at that, I'm going to have the negative 5 and a positive 1. If I did it the opposite way, it would be 5 take away, we'd have a negative 1, it would be a positive 4. In this case, I just want to double check all my numbers work out. So 1 times r is r, and then r times negative 5 is negative 5. And when I add those two together, negative 5 plus 1 is going to be 4. And so there I factored it as far as it can go. Now we're going to go ahead, we're going to have you try a 1 or 2 problems underneath on the Google fake quiz that lets you go ahead and practice. And if you get done with those and you don't get the right answer, it should have a video that goes through and shows you how to get the right answer. If you put the answer in different than the way that the computer's looking for it, when I check your answers, if you see that it's close, sometimes people are, instead of just having a parentheses here, they're putting a time sign, and the answer says it's wrong. It's not as important whether the quiz is marking it wrong. I'm not giving it the grade based on what's actually the score that you're getting there. I want you to watch the videos after to see if you've done it correct. So if you know you're doing it correct, that's really what's most important right now.